Hi, this is the first series of vlogs that I will be doing regarding Stewart, Calculus, 6E, Single Variable, Chapter 3. I'm going to start on Section 5 first, which is called Implicit Differentiation. So this is probably one of the harder sections, and then once we get to this, we'll do related rates next, okay? I copied the examples 1, 2, 3, 4, and I'm going to do it in 3 parts because it is pretty huge. So, part 1, I'm going to go over the concepts and ideas for implicit differentiation. Do one example. Part 2, I'm going to do example number 2 and 3 from the book. And part 3, I'm going to do example number 4, which is one of the hardest questions. There is example number 5, which is part of trig inverse functions, and we will probably not do that because that's part of BC. So this is only for AB students. So let's get started. Before we look at implicit differentiation a little bit, let's look at the function or relation, something like this: y cubed plus y squared x is equal to 5, let's say. Well, if we try to solve for y, we can factor out y squared. You end up with y plus x is equal to 5. You cannot solve for y equals. It's almost impossible. So as a result, we have to implicitly differentiate this. Explicit functions like f of x equals a function of x. We can say y equals dot dot dot, and only x's are on the right hand side. So let's do a little bit of concept of implicit differentiation. The derivative with respect to x is equal to what? Well, you know that that's equal to 1 because your teacher told you, right? Or you did the work yourself. The slope of 1x is just 1 right there. But we can also do it this way. The derivative with respect to x of x would be dx over dx. What's dx over dx? The instantaneous change of x with respect to the instantaneous change of x, you end up with just 1, which is actually a better true statement. So let's try some more examples. What's the respect to x of x cubed? Using the power rule, you end up with 3x squared times dx over dx. That's just 1, which is equal to 3x squared. What's the derivative with respect to x of y cubed then? Well, using the power rule, you end up with 3y squared times the derivative with respect to x of y. That's the chain portion right there. That becomes dy dx. Or sometimes we refer to this as y prime, right? So that becomes 3y squared y prime. Let's do a couple of more examples to get you started, and then we'll do example number 1. So let's get example number. Let's get some more examples. What's the derivative with respect to x of sine of x plus y? Well, the derivative of sine, right, is we know that for sure, which is cosine. The inside stays the same, which is x plus y, times the chain portion, the derivative with respect to x of x plus y. We know this, the chain portion, the derivative of x is 1, plus the derivative of y with respect to x is just dy dx. That times by cosine of x plus y. Got it? Okay, so let's do example number 1, which is located right over here. And we'll stop here. It should be about 10 minutes or so. Example number 1, I believe example number 1 is on page 208. Page 208, example number 1. You have the equation is x squared plus y squared is equal to 25. And part A says you're trying to find dy dx. Okay, so how do we do that? Well, we start with the equation first, and I'm going to use red pen here. I'm going to take the derivative respect to x on the left side, the derivative respect to x on the right side. So what do you end up with? What's the derivative of x with respect to x squared? That's going to be 2x times dx over dx, which is just 1. We don't need that 1 later. The derivative of y squared is going to be 2y using the power rule times dy dx. And on the right side, we take the derivative of 25, which is a constant, which is just 0. Let's just rewrite this. 2x plus 2y times, instead of calling it dy dx, sometimes a lot of teachers, they'll call it y prime. Is equal to 0. We move the 2x term to the right side by subtracting 2x to both sides. So I'm going to take out minus 2x and clean that up a little bit. And then divide it by 2y. Get rid of that because it's being multiplied by y prime. So y prime is equal to negative 2x over 2y. The 2's cancel, you end up with negative x over y. So that's part A. Part B says now at 3, 4, find the equation of the line. So we plug in y prime is another word for derivative. So we plug in 3, 4, negative 3 over 4, you end up with negative 3/4. That's your slope. You have your point, you have your slope. You're going to use point slope form. This is for part B. Part B says y minus y1 is equal to m parentheses x minus x1. So you have your slope, you have your point. It's called the point slope form. Y minus y1 is 3. I'm going to label this x1, y1. That way you know where your x1, y1 is. Y minus 4 is equal to negative 3/4 times x minus 3. And on your AP exam, you should keep it as point slope form. You don't want to distribute that out, add 4 to the right side. You can. It's a little bit extra work. You might make mistakes. AP says this is just as good as slope intercept form. Good luck, guys. I will do example number 2 and 3 a little bit later on. Thank you.